Hello, I'm Huaying from Hokkaido University. This video is a presentation for the paper evaluating the capability of video question generation for expert knowledge elicitation done during my intern in Omron X. We study video question generation in our research for the motivation of using LLMs to consult human experts to elicit expert knowledge. Different from conventional VQG that aims at knowing the visible contents, we focus on invisible knowledge behind the observed scene. When using LLMs to generate questions, it is necessary to judge the quality of the question. Therefore, our research starts with the question: what makes some questions more effective than others? Our answer is, effective questions should lead to comments that are specific to the target's video segment. To realize this, we propose a retrieval-based question evaluation framework requiring a retriever to calculate the similarity between query and candidate comments. Our contributions are concluded as follows. We propose a metric that evaluates the performance of video question generators. We propose a novel dataset, EGO-EXO-ASK, and the benchmark protocol for VQG. We also conduct evaluation on a series of video question generating settings with multiple multimodal LLMs. First, we construct the dataset EGO-EXO-ASK. This dataset contains QA pairs combined with video segments. These QA pairs are partially used for training the retriever we used for our framework and partially used as a benchmark protocol for VQG. We first format the original data from the EGO-EXO40, a great work that contains expert commentary with timestamps for each video. The example is shown below. The formatting is conducted by an LLM. Next, according to the formatted comment, here, it is also used as answer. We use the LLM to generate questions for each answer. A verification and regeneration process is also conducted to ensure the quality of the QA pairs. A few examples are shown below. Finally, the generated QA pairs are assigned to video segments according to the timestamp. After obtaining the EGO-EXO-ASK dataset, we can now train the QA retriever and use it for question evaluation. The question retriever we used is a sentence BERT for calculating the similarity between questions and comments. Given a question, we use it as a query to retrieve comments in the retrieval pool. The retrieval pool is constructed by positive and negative comments, where negative comments are extracted from similar things in prior. If a question can retrieve any positive comment at top K, we regard it as a good question. Now, let's see the experiments. We first show the statistics of our EGO-EXO-ASK. 1,237 segments are used for VQG validation. We conduct VQG on these segments with multimodal LLMs, including QN, Intermedio, and Video Lava of similar size. Note that gold means we use the question generated in EGO-EXO-ASK with seeing the positive comments. We provide the MLLMs with different contexts. From the table, we can see that gold, an ideal upper bound, performed the best, while random performed the worst. Also, providing MLLMs more context, improving the metrics. Especially, questions generated with EGO videos with captions, which are annotated on EXO camera videos, yield best scores. These results indicate that our evaluation framework and metric are reasonable. We also have some qualitative results of generated questions and corresponding evaluation. There are few failures that improperly score the question, and this may be caused by suboptimal negative samples in the retrieval pools. That's all for our paper, and thank you for your listening.